Today's video is about 8-3 trigonometry. What I'd like you to do today is glue your side sheet right at the top. You're going to be doing your math work and calculations at the bottom. Make sure you organize them in a way that you can tell where questions 2, 3, 4, and 5 are. We're going to go over questions 2, 3, 4, and 5 in the notes, and you'll be responsible for filling in these 4 by yourself. The other thing you're going to need is 3 markers. And I'd like you to, in 3 different colors, copy down this SOHCAHTOA somewhere on your notes. You could put it at the very bottom or at the very top, it doesn't matter. And of course, the SO is the sine, being the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the T is the tangent of the opposite over the adjacent. For these notes, the only thing you need is your worksheet, the trigonometric ratios table, and your 3 abbreviations for sine, cosine, and tangent so that you can remember the ratios. In this first slide, I'm going to go over the example, and since it's too small, I redrew it. The first thing I do is I take a look at the angle that was given to me and the sides as well. Now, in relationship to this angle, this is the opposite side and this is the adjacent. If I know I'm given the opposite and adjacent, that means I'll be working with tangent. Now, to set up my ratio, I'd write the tangent of 22 degrees, or the tangent of the angle, is equal to the opposite length divided by the adjacent. The opposite is unknown, so I wrote x, and the adjacent was given the value of 5. Now, I know the tangent of 22 degrees. It's in this table in one of these columns, so I'm going to need to look for it. The tangent of 22 degrees, I'm going to zoom in as much as I can, is right here. Here's 22 degrees. This is sine, cosine, and here, right here, is tangent, 0.404. So I substituted the tangent of 22 degrees in for, because that is what the tangent of 22 is. And now I need to solve for x. So I have 0.404 equals x over 5. They're dividing by 5. What's not shown on your paper is that I multiplied by 5 on both sides. Now, what is 5 times 0.404? Well, I did that math down here to get 2.020. Now, they asked me to round to the nearest hundredth. This is the tenths place. Excuse me, this is the hundredths place. So I look at the thousandths place to see if that value changes. It doesn't. That means that the opposite length is approximately 2.02. So for this question, the first thing we're going to do is start off with the angle that's given, and we're going to look at the sides that are shown on the triangle that they'd like us to pay attention to. When I look at this angle, the 7 is opposite that angle. So I'm going to go ahead and label this opposite. This side right here is either going to be the adjacent side or the hypotenuse side. Now, since this happens to be across from the right angle, then I know this is the hypotenuse. Now from here, I'm going to look at my trig functions, and I'm going to ask myself which of these ratios is going to be best for this problem. Which one uses opposite and hypotenuse? Well, that's going to be sine. So the sine of the 36-degree angle is going to be the ratio of the opposite over the hypotenuse. The opposite side is 7, and the hypotenuse is unknown, so I'm going to call that x. Now the first thing I need to do is solve for x. That means the x needs to be alone. So the first thing I'm going to do is I'm going to multiply by x on both sides to bring the x out of the denominator. When I do that, I get x times the sine of 36 degrees equals 7, because my x's become 1 over there. Now I'm getting close. I need to get the x value alone. They're multiplying by the sine of 36, so I'm going to divide by the sine of 36 degrees on both sides. This becomes 1, and I get x equals 7 divided by the sine of 36 degrees. This is where I'm going to go to my trig table, and I'm going to find the sine of 36 degrees. And you can actually see it right here. Here's 36 degrees, and this first column is sine. That means if I want to find what x is, I'm going to have to take 7 and divide it by 0.5878. Well, this is actually kind of a complicated division problem, so I'm going to go ahead and bring this down. and show you what happens. So this problem right here, in order to find it, I'm going to have to do 7 divided by this fraction, by this decimal. The first thing I do is move this decimal place over 4 places, and I'm going to move this decimal place over 1, 2, 3, 4. That means my decimal place is here, and that 7 divided by 0.5878 is the same as 70,000 divided by 5,878. Now, if only I had a magical way of showing you the math already done. Oh, look, here it is. Let me move my basketball. Okay, I actually want you to copy this down so you have the math. What I did is I divided 70,000 by 5,878. I did all of this math, and I did it out to 3 decimal places because if I'm going to round to the nearest hundredth, I need to know what this number is. When I finish, I end up getting, here we go, x is approximately, because this keeps on going, 11.908. Now if I'm going to round to the nearest hundredth, I'm going to look at the hundredths place and then the thousands place. The 8 is going to affect the 0, so that means x is approximately 11.91. Okay, for question 3, again, we're going to look at the angle that they've given us, and then we're going to look at the 2 sides that they want us to take a look at. In relationship to this side, to this angle, I'm noticing that this side right here is adjacent to it. It's really close. And this side right here is either the hypotenuse or opposite. Since it's across from the right angle, it's hypotenuse. Now I look at my trig ratios to find one that includes adjacent and hypotenuse, and that's going to be cosine. So now I can set up my proportion. The cosine of 12 degrees is equal to the adjacent value, which is unknown, over the hypotenuse. Now lucky for me, the x is almost by itself. So the only thing I need to do is move this divided by 3. So I'll multiply by 3 on both sides. And I end up getting x, because this cancels out to 1, x equals 3 times the cosine of 12 degrees. Now we're going to need to find the cosine of 12 degrees. So I'm going to go ahead and zoom in. Okay, here's 12 degrees. Here's the sine, and here's the cosine. So 3 times 0.9781 will be what x is. So all I'm going to have to do is a little bit of math here. So I'm going to take 0.9781 and multiply by 3. And 3 times 1 is 3, 3 times 8 is 24, 3 times 7 is 21, plus 2 is 23, and 3 times 9 is 27, 28, 29. I've got 4 decimal places, so 1, 2, 3, 4. So x equals 2.9343. I'm going to round to the nearest hundredth, so I check to see if my thousands place is going to affect it. I'll move this up just a little. And it doesn't, so I get x equals 2.93. And that's my answer. That's what the adjacent side is. For this problem, I'm going to start again with the angle, 62 degrees, and I'm going to label the sides that have been shown to me. This side right here is opposite my angle, and this side right here is adjacent. It's not across from the right angle, so it's the adjacent side. So I look at my trig functions, and the only one that includes opposite and adjacent is tangent. So the tangent of my angle of 62 degrees is equal to the opposite measurement over the adjacent. Now I'm going to need to get my x value alone. So I'm going to multiply by x on both sides first to take it out of the denominator. And I get x times the tangent of 62 degrees equals 7.4. I'm almost there. I need to get that tangent of 62 degrees out of there. So I'm going to divide by that on both sides. And I end up getting x is equal to 7.4 divided by the tangent of 62 degrees. Now I need to go to my trig table to find the tangent of 62 degrees. I have to move this over a little bit. Here we go. Okay, here's 62 degrees. Here's the sine, cosine, and right there's the tangent. So that means I'm going to have to do this calculation. 7.4 divided by 1.8807. Let me show you what that calculation actually looks like. If you're going to do that math, you're going to take 7.4 and you're going to divide it by 1.8807. Now I have to move my decimal place 4 times, and I have to do that here too. That means my new decimal place is there. I add in my zeros, and here is the actual calculation. Let me move this in a little bit. So when you take 74,000 and divide it by 18,807, which is really what we just did here when we moved the decimal places, please copy this calculation. I get 3.934. So that means x is approximately 3.934. I'm going to mark my hundredths place and see if it's affected by the thousands. My answer is x is approximately 3.93. And that's my answer. Once again, I'm going to look at the angle they've been given, and I'm going to look at the two sides. This side is the opposite side compared to the angle, and the 12 is opposite the right angle, so it's the hypotenuse. I'm a pro now, so I can go straight to sine. So I know the sine of 74 degrees equals the opposite over the hypotenuse. That's the proportion I'm setting up. I need to get my x alone, so I'm going to multiply by 12 on both sides. So I know that 12 times the sine of 74 degrees will give me my x value. I'm going to look up 74 degrees, and here it is right here, and right there's my sine value. So I'm going to substitute that in. So 12 times 0.9613 is what my x value is. So I'm going to have to do that calculation of 0.9613 times 12. I'm going to get 6, 2, 12, 19, bring down my 0, and then it's actually just going to come down exactly as it is, 3, 1, 6, and 9, because I'm multiplying by 1. When I add that together, I get 6, 5, 3, 15, and 11 with 4 decimal places. That means x equals 11.5356. Now, since they asked me to round to the hundredths, I check my thousandths place, and I see that x equals 11.54. Now, what I'd like you to do right now is keep in mind these 5 examples and finish the rest of this sheet. Make sure you show all of your math work below. Good luck.